All right, today we're going to talk some more about absolute values, and now we're going to talk about absolute value inequalities. So we're going to solve absolute value inequalities, and we're going to do some real-world examples that also have absolute value inequalities. Now, absolute value inequalities are very similar to absolute value. They do have two answers, but remember when we do inequalities, having two answers means we have to worry about whether or not they say and or. They become compound inequalities, which we worked on last week. So some basic ideas with compound inequalities or absolute value inequalities. When we had an absolute value of n, we did x is greater than n. X equals n and x equals negative n. We had the positive and the negative case. Well, the same thing is going to happen here with the less than and the greater than. With the less than, we have a less than with an and a greater than becomes an or problem. Now, there is one additional thing that we have to do. We do have the negative case, but if you notice with the negative case, we also end up switching the sign here. So we have the original case, the positive case, nothing switches. But on the negative case, not only do we make it negative now, but we also switch the sign from less than to greater than, or from greater than to less than. Less than ones are ands, greater than are ors. Also, remember when we had the equal to a negative, we just wrote no solution. Now, that's not always true with these inequalities. A less than a negative or an and negative is no solution. That's still the same. But when it's greater than or the or problem negative, then it's an all reals. It's actually everything works. So there are two different possibilities, so we have to be aware of that also. I'll show you those examples as we go. So let's try our first example here. So here we have the absolute value is less than or equal to 12. So we're going to split it into two cases. See, we're going to write it as s minus 13 is less than or equal to 12. And because it's a less than, it's an and. S minus 13 is greater than negative 12. So notice what happens over here. Not only do I make it negative 12, but I also switch the sign to a greater than. So case 1, we're going to go ahead and solve that. And case 2, we're going to solve that one. So we add 3 to both sides, very similar. We talked about how they're very similar and we can do both of them at the same time. So we're going to go ahead and do that. So s is less than 15 and s is greater than or equal to negative 9. Now this is an and case. Now remember, ands tend to be the inside. So we're talking something that's greater than negative 9 and less than 15. So when we graph that on our number line, we have negative 9 here and 15 here and the points in between. This is how we can go ahead and write it using that and formula that we can do. That doesn't say that it's and, but we can write it that way. So greater than negative 9 and less than or equal to 15. Here's a case that equals a negative. Remember, we have those different possibilities. So with a negative, we always just wrote no solution, but with the less than, we have to take a look at our chart from back here. A less than negative is a no solution. So this one still ends up being no solution. So it's the empty set or the no solution set. It's when it's greater than that it's the other way. So let's try another one. Let's try the greater than ones. So this is greater than, so this is going to be an or problem. So we're going to take a positive, and then we're also going to do a negative case, right? So we have 3y minus 9 is greater than 9, and 3y minus 3 is less than negative 9. Again, as we switch to the negative, we do switch that sign, so be careful with that. Add 3 to both sides. 3y is greater than 12. 3y is less than negative 6. Divide by 3. You know, if it was negative 3 here, we would have to switch the signs yet again. But it's just positive, so we don't have to. So y is greater than 4, and y is less than negative 2. Now we're going to go ahead and graph this. Remember, these are or problems. And when you're dealing with ors, you do tend to get the outsides. And that's what we're going to go to get here. Remember, it's always two sections for an or problem. So we go ahead and do that, and we write it as an or. So less than or equal to 2, less than 2 is here, and greater than 4 is this way. So we get both of those answers. Now here's the or equaling a negative number. Again, when that negative happens there, that should be a key concept for you. So when it's greater than or equal to that negative number, then that's where we get an all reals. Everything works, actually. No matter what number we plug in, it will give us a correct answer. So we can just fill in our entire graph, or you can say all reals. All right, how do we do this if it's a real world problem? The average rainfall in California is 23 inches. However, the annual rainfall can differ by 10. This 10 is what's going to be on the opposite side. So when we're looking at, this is where the 10 is going to go. The original value, the value that they give us, the 23, that's going to go in here with the x. So notice how they do this. The 10 goes over here by itself, and then it's x minus 23. It's always minus whatever the number that is there. And then we could go ahead and solve this. We can make both of our cases, our case 1, which is just the positive, and then the case 2, where it's the negative, switching the sign and making it greater than negative 10. And we solve that, and x is greater than 13. Ignore this first one. That's just more confusing than anything else. So we're talking about less than or equal to 33 and greater than or equal to 13. So that's the range of rainfall. It was either between 13 or 33. So what about this one? The hitter's batting average stayed within 0.150 of this number. Now, this is the original number, so that's got to go inside our A. It's A minus that. And then we want it less than or equal to the 1.15. So we have D here. So that's how we do these real world problems. The whatever the value is goes here, and then how much it differs or stays within goes here. And that's what I have for you today.